Welcome back to Physics 142. So we've been talking about electric potential and the idea of electric potential energy, and understanding that these sort of energy methods, these electric potential methods, are another way that we can solve problems involving charges and how charges move around. Where we're going to go next in this course is I want to move now into some more practical applications of these ideas of electric fields and electric potential. And to do that, we're going to start by looking at applications in circuitry. And we're going to start with a specific kind of circuit element called a capacitor and discuss the idea of capacitors and capacitance. So this video is going to be an introduction to capacitors and the idea of capacitance. So what is a capacitor? Well, I've written it down here. A capacitor is basically an electronic device that we have for storing electric potential energy. It's a way that we have to store electric potential energy. And how do we do that? Well, what we end up doing is you take a couple of conductors, so it's going to consist of a couple of conductors. And what we're going to want to do is we're going to take those conductors and separate them by an insulator or by a vacuum. So we'll say that a capacitor consists of a couple of conductors separated by an insulator or vacuum. And how that gives us, how that stores potential energy, well, the way we think about it is I want to draw a circuit for you. So what we do when we talk about circuits is we usually represent wires as lines, and we represent sources of electric potential. Something like a battery is something that has a source of potential. What we do is we draw a long line and a short line, right? And the long line represents sort of the positive terminal of the battery. The short line represents the negative terminal of the battery. And we say the positive here, that's up at high potential. This is where you get positive charges accumulating. Those positive charges, right, those are where you have high potential. The negative down here, that's at low potential. And what we usually do is we draw wires coming out of that battery. All right, so you can connect some wires to the battery. And then the symbol for a capacitor is going to be just a couple of even length parallel lines. All right, that's going to be the symbol for a capacitor. And basically the idea here is that you have one part of the capacitor that's going to be at high potential and another part that's at low potential. And so, or another way of thinking about it, we're going to accumulate a bunch of positive charges on the top, right? So charges, they're going to flow out through the wire. The wire is a conductor, right? This is a metal plate. It's also a conductor. And so you get some positive charges that are going to accumulate over here, right? And maybe you get some negative charges that flow out here and accumulate down here, right? I should mention that in circuits, this is just a brief aside, people, even though we know it's usually the positive charges are sort of locked in the lattice, it's the negative charges that move around. For circuits, people often will talk about positive charges moving as just another way of thinking about it. And so there's that's sort of the convention here. All right, so it's okay to, and most of the time when people talk about circuit flow and that, they actually think about the motion of positive charges, even though we really know in our heart of hearts it's a negative charges that are moving. So basically, going back to this particular circuit though, we're going to accumulate some positive charge plus Q on one side, and we'll accumulate some negative charge minus Q on the other side. And the idea is, well, if you've put an insulator here, something where charge can't flow, or like a vacuum, then the charges can't go from one to another, and you're going to keep some charges up here, some charges down here. That creates keeps a nice electric potential energy, and is then, or electric potential difference, And if you have electric potential difference with some charge, that's going to store potential energy, right? So basically what happens then is when we connect to a source of electric potential difference, like a battery, you're going to store some charges on the top and store some charges on the bottom. All right? All right. People also just, they talk about this as a passive circuit element. It's just there to store these charges. Now, it'd be nice if we could have some way of measuring how much potential energy it's storing, or how good it is at storing the potential energy. And the way we talk about how good something is at storing potential energy is we talk about its capacitance. Right? And so capacitance is basically a measure of the ability of the capacitor to store energy. A measure of the capacitor's ability to store electric potential energy. All right, so capacitance is a measure of how to store it. And the way that we define capacitance is we say the capacitance C, right? We define the capacitance C, and we define that to be the amount of charge, Q, that you get stored on one of these plates here, divided by the potential difference between the two plates. So if you have a battery that can create some sort of potential difference between those two plates, basically the more charge you can build up for that given potential difference, the more charge you can put on these plates, the better it will be at storing potential energy. Because remember, potential energy is actually charge times potential. So if you can store more charge for a given potential, you're better at storing potential energy. I should also note that it doesn't really matter if we're talking about positive or negative charge. Capacitance is always a positive number. So we usually put this formula in absolute value signs, all right? So we'll just say that again. Capacitance is how much charge per change in potential, all right? So that means that the units then must be the units for charge, that's a coulomb, divided by the unit for potential difference, which is a volt. So it's how many coulombs of charge you can accumulate for a certain potential difference in volts. And we give 1 coulomb per volt, we give that a special name. We use the letter F for it, and that's called a farad, F-A-R-A-D, 1 farad of capacitance. I should mention that 1 farad of capacitance is a huge value that for circuits you might use typically in a lab or in much circuitry. They're more likely going to be measured in something like microfarads or nanofarads. 10 to the minus 6, 10 to the minus 9 farads would be more normal circuitry level. 1 farad is just an incredible amount of capacitance. So that is the idea of capacitors, capacitance. If the units, I should mention that the capacitance ends up just depending on the size and shape of the capacitor and maybe what you've stuck in the middle. So it's just a property ultimately of the physical materials that you're using, how big it is, what shape you've made it. And so in the next video, I'm going to show you how we calculate the capacitance of just a capacitor that looks exactly like this, a parallel plate capacitance. And we'll see that it just ends up depending on the geometry.